Hi everyone, good morning. This is Miss Billingsley. Today we're going to be learning about arc length and sector area. Yesterday we reviewed a couple of formulas and vocabulary that we are going to need in this new unit on circles. Today we're going to extend that knowledge a little bit and talk about some new things, arc length and sector area. Let's first start with the definition of arc length. Okay, yesterday we reviewed the formulas for area and circumference. We're going to be using these to find arc length and sector area because essentially these are just a portion of either the area or the circumference. So arc length is going to be a portion of the circumference. Okay, a portion of the circumference. So we find this using our formula here. Go ahead and write this down with me. X over 360 times 2 pi r. 2 pi r is our circumference formula, and this tells us what portion we're taking. X is the central angle here, so the measure at the center of the circle, and then the arc length would be this portion of the circle here, like the pizza crust on a pizza. Okay, so in order to find this, we're going to take the central angle divided by 360. So what portion of the whole circle times the whole circumference, 2 pi r, and of course r is our radius, which can be found from the center to any outward point on the circle. So let's now write down the definition for sector area as well as its formula. A little bit different because this is a portion of the area. Okay, the formula is very similar. We're going to use x again, which is our central angle. We're going to be using our radius again because we're taking a portion of the entire area, which is pi r squared. Okay, so we just need the central angle and a radius in order to find either the arc length or the sector area. I'm going to pause here and make sure everybody has this written down. Go ahead and write this in your notebook if you don't yet. Now I want us to try a couple examples. I'm going to try one with you, and then I'm going to let you try one on your own. Okay? All right, here we go. First, let's try out an arc length problem together. I'm looking at example number 1 first, where we want to find the length of arc EV. Okay, so arcs are annotated with this little curve on top that we see here when we see them in writing, and that just tells us the endpoints of the arc. So this arc EV would go from E to, why do I keep saying V? I mean F. EF. Okay, so EF, we have a radius of 6 meters. That's from the center point out to E, and then my central angle here notated in the middle of my circle, 120. So we're going to plug those things into our formula. We take x, which is 120, over 360. So that tells us what fraction of the circle we're looking at. Then we're going to multiply it by the total circumference, which is 2 pi r. Remember, we said our radius was 6. Okay, so the setup is that simple. We're really plugging two things in. The answer is where things can get a little bit complicated. A lot of times in this standard, we want to leave our answers exact, and that means in terms of pi. We don't want to type pi in the calculator because then it's going to give us a decimal, which we will inevitably have to round. So in order to get an exact answer, let's get an exact answer first. In the calculator, we're going to type everything except for the pi. So I'm first typing my fraction in, 120 times 3, or divided by 360 times 2 times 6. So I skipped typing in the pi, and then I get 4. So my answer is going to include the pi. I just didn't type it in the calculator. Our final answer in exact form would be 4 pi meters for my arc length here. Okay, so that's an exact answer. That's typically what we prefer, but you may sometimes be able to round. So if we did round it, we would just type that all in again and then include pi, or just this time do 4 times pi, which gives us about 12.57. So all depending on your instructions there, you can either leave it exact or provide a rounded answer. Okay. Okay, let's go ahead and try the next one. I want you to try this one on your own, but first I'm going to give you a couple of hints and things to look out for, like how they are giving us the diameter. The diameter is 24 centimeters, and we want to find the length of CD, which is going to be this portion of the circle. We've got a central angle of 60 degrees. If my diameter is 24 centimeters, how long is my radius? Very good. My radius would be 12 centimeters. So keep that in mind as you set up your equation here. Okay. What is the arc length of CD? If you said 4 pi, again, you are correct. This is a different circle, but we still end up with that same answer. I'm going to take 60 out of 360 times 2 pi r. Okay, again, when we type this in a calculator, we have different proportions, but we end up with the same answer, and that's totally okay. And this time my units would be centimeters, okay? Which means our approximate answer would be the same as well, about 12.57. So depending on what central angle you have and how big the radius is, that will all play into the size of the arc. Okay, now let's try a sector area. So this is like a shaded portion of the circle. We're going to do number 1 together, and then you guys will try number 2. Okay, so with sector area, we're looking at, like I said, this shaded portion. So I'm wanting to know how much area there is here. The thing to remember about area is that our units are going to be squared because it's like a two-dimensional measurement. So we have, again, a central angle given to us that we're going to put over 360. So we have 120 out of 360 times the total area, which is pi r squared. Here, our radius is 16. So again, the setup isn't too bad. We are plugging in 2 numbers, our central angle and our radius. And we're going to type this in our calculator. So again, I'm going to type everything but the pi to get an exact answer first. First 120 out of 360 times 16 squared. We're squaring the radius there. So I get about 85.3, which is repeating. I prefer that in a fractional form so that we don't have to round or anything. So about 256 thirds pi would be our final answer there. And of course, our units is meters squared, okay? If you need to put a little star here for yourself to remind yourself that the units there are squared, that would probably be a good idea. Okay, so 256 thirds. If we multiply that by pi, we would get our approximate answer, which is about 268.08 meters squared. So this is a big circle. Okay, so all we're doing is plugging in the central angle and the radius. If you're not given the radius, you may have to calculate it, like on the last one where we divided the diameter by 2 to find the radius. Okay. All right, last one I want you to try. You may need to draw yourself a picture since there's not one given, but we have a circle with a radius of 12 inches. We want to find the area of the sector whose central angle is 120 degrees. You should be able to do this without a diagram, but it does help some people to have that visual. So if you want to draw yourself a picture, go for it. Okay, what would the area of that sector be whose radius is 12 and central angle is 120? Very good. If you said 48 pi, that is the correct answer. We're going to take 120 out of 360 times pi r is 12 squared. So our exact answer would be 120 divided by 360 times 12 squared this time, which gives us exactly 48 pi. And of course our units are inches squared this time. Okay, an approximate answer would be 150.8, around 150.8. Okay, and that's all there is to it. Okay, if you have any questions, please email me or Miss Martinez, and we hope to see you guys soon. Stay warm.